Good morning, students. In this thermal engineering subject, today's unit is about refrigeration. This is the fifth unit in our syllabus, and the sixth unit is about air conditioning. In this fifth unit, refrigeration, we need to deal with vapor compression system and vapor absorption system, which are all the types of refrigeration systems normally we are using in our day-to-day life. Before entering into the topic refrigeration, we need to understand what is the difference between refrigeration and air conditioning. You see, refrigeration is simply maintaining the temperature of a space below that of the surroundings. Maintaining the temperature below that of surroundings. But in air conditioning, according to the atmospheric temperature, we may need to heat the room, or we may need to cool the room, and also we need to control the humidity, air velocity, and air purity. So these are all the factors required in air conditioning, but in refrigeration we need to maintain the temperature below that of surroundings. To achieve this, we are using a device called refrigerator. In that, a refrigerant is flowing inside tube. This refrigerant is the working substance which goes in the refrigerant cycle between colder and hotter regions. There are several refrigeration systems, but in our unit we are going to deal with vapor compression refrigeration system and vapor absorption refrigeration system. First, we will look into the schematic representation of a simple refrigeration system. This is the diagram. You see, low temperature reservoir is here. Low temperature reservoir is the space to be cooled. Then high temperature reservoir is here. This is the atmosphere. Normally we are supplying this heat rejected to the atmosphere. According to the second law of thermodynamics class statement, it is not possible to reject or remove heat from a low temperature reservoir to a high temperature reservoir without using an external device. So to transfer heat from low temperature to high temperature device, we need an external device. Here it is called refrigerator. This refrigerator removes a small amount of leakage heat from this reservoir, and it takes the work input and it converts this work input and heat absorbed into total heat, and it rejects it to the atmosphere. Here the work input is the electrical energy supplied. This is a schematic representation of refrigeration system. The COP of this system is, as we know, as we studied in thermodynamics, we know COP. COP is simply heat absorbed from the low temperature reservoir divided by the work input. Normally we require a system with higher COP. To achieve a higher COP system, we need to reduce the work input. Then this is a simple vapor compression refrigeration system. There are four major components in a vapor compression refrigeration system, called compressor, condenser, expansion valve, and evaporator. We start with evaporator. Evaporator is the space to be cooled. If I need to maintain a temperature around minus 30 degrees centigrade in an evaporator, I have to remove the wastage heat or leakage heat from this evaporator continuously using this device. In this tube, refrigerant is flowing. The refrigerant enters as liquid and a very small amount of vapor. This liquid refrigerant absorbs the heat. It's called latent heat. It absorbs this latent heat and it totally changed into vapor. Here it is normally a low pressure vapor. This vapor is supplied to a compressor. In this compressor, we are compressing this vapor refrigerant. So it is converted into high pressure vapor. This high pressure vapor is supplied to a condenser. Normally condenser is used to convert vapor to liquid by removing heat with the aid of some cooling water or some other device. So here enters the vapor, high pressure vapor. Then the cooling water is circulated in another circuit. This cooling water takes away the heat from the refrigerant vapor. Here a small amount of sensible heat from the vapor and also a large amount of latent heat removed from this vapor. So the vapor is completely converted into liquid. This liquid is again expanded in the expansion valve. Normally expansion valve is used to reduce the pressure. So this is an irreversible device in which the enthalpy is same from at the inlet and also outlet. So after expansion valve, the low pressure liquid refrigerant and a very small amount of vapor enters the evaporator. Again this cycle continuously runs to cool this space. You see the TS diagram of this vapor compression refrigeration system. If you see, this is the liquid line, then this is the vapor line. This is point 1. Actually point 1 is before compressor. So this is 1. At the entry of compressor it is saturated vapor. So the point 1 is lying on the vapor line, saturated vapor. In the compressor we are compressing this vapor, so it is little bit superheated. So this is state 2 after compressor. So this is from process 1 to 2, it is little bit superheated. We are considering it as reversible adiabatic process or constant entropy process. This is point 2. But in the condenser, after condenser, the state of refrigerant is completely liquid. So point 3 is lying at the outlet of condenser. So I need to put this point 3 on the liquid line. So to reach this refrigerant from point 2 to point 3, first we need to cool this refrigerant to the vapor line, then removing latent heat to reach the liquid line, like this. This is happening at constant pressure. Here the temperature will vary because it is sensible heat, but during the phase change temperature is constant. So this is point 3. After point 3 we have an expansion valve which reduces the pressure of this refrigerant. So it is an irreversible process, so I am indicating it with a dotted line. This is point 4. So point 4 is after expansion valve. You can see this point 4 is lying between liquid line and vapor line. It means that it is a mixture of liquid and vapor. Normally mostly it will be liquid and a small amount of vapor. Then after 4 we have this evaporator. There we have only a phase change process. It is a constant temperature and pressure process. So cycle starts from 1 and 2, 3 and 4. So we are considering this 1 to 2, 2 to 3, then 4 to 1 are all reversible process, but 3 to 4 is an irreversible process. So together we say it as it is an irreversible cycle. So this is a simple explanation about simple vapor compression system. You can see this is the backside of our home refrigerator. In the top side you can see the evaporator coils where the heat is removed by the refrigerant. So normally in the home refrigerator, the top surface is in the cooler side, the bottom is little hotter side. See, you can see 3 degree minus 18 degree. So this is the compressor. These are all condenser coils. So you can see this diagram. Normally the electrical supply is connected with the motor. The motor runs the compressor. So after compressor we have this condenser, then expansion valve, then evaporator, and again compressor. So this is the simple layout of domestic refrigerator. You can see this is the actual component in the home refrigerators. This is the compressor, this is the expansion valve we are using, this is condenser, this is compressor, another diagram. This is another expansion valve we are using in the refrigerators. You can see the refrigerator comes in. There is a very small space in the for the flow of refrigerant. Because of that, the pressure reduces in the expansion valve. So these are all the devices about vapor compression refrigeration system and explanation of vapor compression refrigeration system. In the next class we are going to deal with vapor absorption refrigeration system, and we will speak about the difference, comparison, advantages and disadvantages of vapor compression and vapor absorption system. After that we will see the details about air conditioning systems. Thank you.